Good morning, everybody. Today we are going to do mathematics, and as you saw on your booklets, we are going to do 3D shapes. I quickly want to show you, oh my goodness, my drawings are all skewed this morning. Okay, we did 2D shapes earlier in the year, and the reason why we call them 2D, because this is the length and this is the width of the shape. Okay, it's got length and width. If in this case it's a rectangle, if I have a square, any of those things, they always have a length and a width. Okay, if I have a circle, it's called a circumference. And if I have a triangle, I'll also have my dimensions, how big the sides are and how high the lines and the angles are from each other. And that's why we call these shapes 2D shapes. Okay, I just want to mention one very important thing. This is called an angle. Now we start first with a dot. As soon as I lengthen the dot and then I have a line, okay? As soon as I have, let me just use these thingies of ours. As soon as I connect, this is a line with another line, I have an angle. That thing is called an angle, okay? We are getting to angles, a whole different topic later on, okay? So this is called an angle. Please don't call it corners. A room's got corners, all right? But in mathematics, we talk about angles. So you will see sometimes when you find worksheets or so, or even YouTube videos on internet, they will talk about corners. That's not mathematically correct. They are called angles. And as soon as I add another line to it, like this, now I've got a 2D shape. Now what we're going to do now is, let me show it this way. I have my square. There's my square. And now I'm going to give it another dimension. Okay, can you see that thing over here? I have the length, that means this one over here. I have the width, is that one over there. But now I have height. So imagine I could have taken, now where did I put my lid? There it is. I could have taken a square like this. Can you see it's a flat? This one already have thickness. So this one is already more 3D than just the lines on a paper. Now, if I take this one, okay, it's got length and it's got width. And now I'm going to add height to it. Okay, can you see? And then I add another one over here. And I continue building. I will get to the building just now. And voila! Let me just get that shape of ours. Then I will end up with a thing like this. Okay, and this thing is called, okay, let me use the smaller one so you can see it better on the camera. Okay, this one is called a cube. Alright, so if you look at this part, the part that you guys can see look like a 2D shape. It's got width and length, okay? But as soon as I turn it this way around, it's still got the length and the width, but now it's got height as well. So 3 different dimensions. So we call these things 3D shapes. Okay, so imagine I take a square like this and I could inflate it and poof, there I get a cube. Alright, so all the sides look exactly the same. Now, the part that you guys can see now, that is called a face. Okay, so it's easy to remember your face, the face of the cube. But remember, I've got this face. If I turn it, there's another face. And if I turn it, there's another face, and another one, and another one. And that side, although it's open, it's also a face. Okay, so if I ask you how many faces does a cube have, let me use the closed one now. Okay, can you count with me? If I hold it like this, I think yes, like this, you will see nicely. I have one at the top, one at the bottom. Then 3, 4, 5, 6. So if I ask you how many faces in a cube, this is 6 faces. All right. On Monday today, you are supposed to build those shapes. Now you will see the white parts are the parts where we put the glue, and the colored parts, I wish I could give it colored. You guys would have loved it. It's awesome. It looks like tins and cereal boxes and all kinds of stuff. Okay, so you have to build them today first, because then you have them on your table, because you don't have these with you, and you can touch your cube and you can go along and figure out all the different parts that I'm talking about now. So a cube's got 6 faces. Then if I look at this square, it's at itself, it's got 4 angles. All right, because it's got 4 sides, it's got 4 angles. But if I look at this one, it also got 4 angles, and this one also got 4 angles. But if I look at the pointy part of my shape, can you guys see this pointy part? This is where this angle and that angle and this angle all connect to make this pointy part. Now this pointy part's name is called a vertex. One vertex, but more than one vertices. Okay, so if I ask you how many faces, you count the flat parts. Okay, 6 faces. If I ask you to count the vertices, 1, 2, 3, 4, 1, 2, 3, 4. So a cube's got 8 vertices. All right, that's the second part that you need to know. We call those properties. If I give you this and I ask you, what do we call this? Yes, it's a marker. Why do you know it's a marker? It's got the shape of a marker. It's got a lid that I can open and I can write with it. So I know it's a marker, and because I cannot rub it out with an eraser, I have to use this pom-pom at the back or a wet cloth. I know it's a dry eraser. I can wipe it off everything, so it's not a permanent marker. It doesn't have ink, so it's not a pen. Alright, so because of those properties, I know this is a marker. So because of the properties that we're discussing now, like the 6 faces, the 8 vertices, I know this thing is called a cube. Now, can you guys see the square that you guys can see now? I have 1, 2, 3, 4 sides in my square. But now I've got 6 squares and they're all connected. That's where you guys pasted them. So those lines where this face and this face are connected, that line over there, can you see it? That is called an edge. So imagine it's like a guy walking, and when he gets to the end of the building, he almost wants to drop off. So he's standing on the edge. Okay, so all these lines where the 2 faces connect are called edges. So if I count them, I'm going to hold it still like this. The 4 at the top, 4 at the bottom, that's 8. And then the height is also 4, so there are 12 edges. Okay, let's have a look at the other shapes that we have. If I look at this, you guys can see this face is a square, but this face is a rectangle, quite correct. Now, this 2 short sides are both squares, and these faces are all rectangles. So now I cannot say this is a cube anymore because they are rectangles. So this shape, it means like I took a square and it went on and on and on the same length without getting smaller. So it's a prism. Okay, It's a rectangular prism. Remember the word prism because we're coming back to it. It's got 1, 2, 3, 4, 5, 6 faces. It's got 1, 2, 3, 4, 5, 6, 7, 8 vertices. It's got 1, 2, 3, 4. So it's got 12 edges. Okay, that is my rectangular prism. They also refer to this as a cuboid. Okay, I will get back to this. There's one that you rather call rectangular prism and the other one a cuboid. I am coming back to that just now. Let me just get it. Where is that one of ours? There it is. Okay, it's also the wooden one. Alright, I want you to see the difference between this one. The short side is a square. This one short side is a rectangle. Both short sides are rectangles. And all the sides are also rectangles. So every face on this shape are rectangles. So this is a rectangular prism. This one, because the two short sides are squares. And these are rectangles. This is a cuboid. Alright, so I'm just correcting myself there. If the two short sides are squares, but the rest of the faces are rectangles, it's a cuboid. But if the short sizes are rectangles like a tissue box, then it's a rectangular prism. Alright, let's continue with our shapes. This one is also quite familiar. If I look at that side, the face is a circle. That side, the face is also a circle. Now in this case, I don't have any edge on the side. The only edges that I have is where this circle connects to this flat circle that I'm holding on. And where this circle is connecting to this flat circle. A flat piece. I'm going to talk about that piece just now. So faces 1, 2, and 3, like a tin cool drink, a cool drink tin. Okay, or a glass, or even my marker. And this is called a cylinder. So it's got 1, 2, 3 faces. It's got only 1, 2 edges. Okay? Does it have any pointy parts? None at all. So no vertices on a cylinder. This is called a cylinder. Now I'm coming back to this part I'm holding on to. Okay, I'm going to show you something totally different there. Then we have this one. I'm sure you guys know this one. Okay, the face that you're seeing now is a triangle. Turn it, triangle, triangle, triangle. Okay, and the bottom side is a square. So if you just look at the triangles with the pointy part, okay, we call this thing a pyramid. Alright, you have seen them in Egypt. This is called a pyramid. But the bottom is a square. So we call this a square-based pyramid. It's a pyramid, but the base where it's standing on is a square. You need to know that because this one is also a pyramid. Triangle, triangle, triangle. But look at the bottom. It's a triangle. So this is a triangle-based pyramid. Pyramid is where the shapes all connect at one vertex, one pointy part. Okay, so it's all the faces are triangles and the base is also a triangle. So it's a triangle-based pyramid. This one is a square-based pyramid. It's called a pyramid because it all connects at the one pointy vertex. Okay. Now keep this thing in mind because I'm going to show you something totally different now. Look at this thing. Now you can say, okay, that's also a triangle. That's a triangle. But this face is a rectangle. This face is a rectangle. This face is a rectangle. Now compare this shape to this one. Can you see the difference? Okay, this is like I took this triangle and I put it all the way and it ended in a triangle as well. This is the same all the way. So that's why it's called a prism. This one, all the parts connect in one vertex, one pointy part. So that's why this is a pyramid. Can you see the difference? All the parts end in one vertex. There are 1, 2, 3, 4 vertices, and that one pointy part is 5. But this one's got 1, 2, 3, and it ends also in 1, 2, 3. So it's a long ongoing shape. So it's a prism. Okay, cool. I hope you guys got that. Then we have this one. Now, the base is a circle, but if you look at this part, what do you know is the name of this shape? Yes, I'm giving it away. It's a cone, or it can even be a partiette. Okay, so this part that I'm holding has got a very odd shape. Now, you guys will see when you build your shapes. This part is half a circle. So I took a half a circle that you guys had to bend this way, and then there was this circle part that you had to connect to make your cone. Alright, so those are the two faces, the half circle and the circle, and that made your cone. What am I missing here? I've got the cube, I've got the pyramid, I've got the rectangular prism, I've got the cuboid, I've got the cone. Just for interest's sake, I'll show you this one as well. Can you quickly count the sides of that 2D shape? Yes, it's 6. So what do we call a 2D shape with 6 sides? Yes, it's a hexagon. As soon as it's more than 4, we call them polygons. Remember, my pentagon, my hexagon, my heptagon 7, my octagon 8, nonagon, and decagon. Can you remember that? That's a bit far away. Alright, so this is a hexagon. But if I turn it this way, you will see it's rectangle, 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 all the way around. And this side is also exactly the same hexagon. So it's the hexagon that I pulled, and it's all the way the same till this side. So it's a hexagonal prism. Can you see the difference? I can take any shape, and if I continue with this shape, it's going to be a prism. So let me quickly remind you before I do the next thing, to remind you, I have 2D shapes because they've got length and they've got width. Then I've got 3D shapes because they've got length, width, and height. Oh, wonder if I can actually do this. Okay, and height. Now it's a thing that I can touch and I can carry it around. The flat part of the shape I call my faces. The pointy parts are called one vertex, many vertices. And the long lines, in a 2D shape, I will call it sides. In a 3D shape, I will call it edges. It's where this face and this face get glued or folded. That's the edge just before the guy fall off my little shape. Okay, those things you guys met with when you were even in year 0, okay, or pre-primary. You learned all those different shapes. But now we're going to look at something different, and that's what you guys used to make the shapes that we gave you to make on Monday. Now, I want to show you something. If I take this square, I'm going to connect it to this square. I'm just going to put them together like that. For now, I'm using a little elastic band. Okay, elastic band. Okay, they're now connected. I'm going to use another elastic band. Oops, drop it. And I'm going to connect it to this one as well. Okay, there you are. Okay, I'm getting there. Can you see I'm almost building a house? There I have another one. Okay, what am I connecting now here? Yes, I put the elastics on the edges and I'm busy connecting my faces. Okay, there's the last edge over there. Okay, so I made a little box. Can you guys see that? and I connected 1, 2, 3, 4 edges. But I'm not done because I can still see you guys through this. So let me attach the top part as well. You guys just need to be patient with me because I need to do it properly and I need to talk to you in the same time. Okay, there's the 5th edge. There's the 6th one, ordinal numbers. 6th edge that I'm connecting. The next one is the 7th one. There we go, the 7th edge. This is the 8th one that I'm connecting. Okay, there we go. This is the 8th one. Alright, but I'm not done. There's still a blank spot, so let me connect that one. So let's go on. Can you guys guess how many edges am I going to use? Yes, it's 12. This is number 9. And this one is number 10. And this one is number 11. Okay. And this one is number 10. Number 12. Sorry, what's my counting now so wrong this morning? Okay. And there I have a cube. How do I know it's a cube? Each of the faces are squares. Okay, it's got 1, 2, 3, 4, 5, 6, 7, 8 edges, vertices, and it's got 12 edges. Now, what I want to show you, I'm going to loosen some of these elastic parts. And I'll show you now why. This is something that you guys had to figure out this morning when you're going to build your shapes. If I open this up, okay, let me think how I'm going to open up. I'm taking off some of the elastic bands and I'm going to open up the shape. Let me take off this elastic band. Okay, open up. I still need to open this one. Okay, I'm going to open up this whole shape. Can you guys see? Whoops, daisy, this one is not supposed to fall off. Let me just attach this one quickly. There we go. We need to work so carefully with this stuff that we don't break the parts because we want to use it again. Now, if you guys were in the class today, I would have let you guys build it yourself. Okay, can you guys see when I open this up? It almost looks like a cross. Can you see? Now, that thing that you see, the green that you see, is now not a cube. It's opened up. This is called the net. It's like the pattern that I have to use to build a square. So you guys got a pattern that looked like that. And you have to paste it first 4 to make it the shape of a block. And then the 2 ends to close it up. So you guys need to be able to identify the 3D shapes. You need to be able to know what's a vertex, what's an edge, what's a face. You need to be able to recognize a shape, a 3D shape, by looking at the net. So in your mind, if I give you a net, you need to be able to think, how am I going to connect the parts? What kind of shape am I going to make? I want to come back to this one. Okay, this cylinder. If I should cut this out, I will have a circle on one side. I don't think we have circles because they can't attach. I have a circle on the one side. I will have a circle on the other side. And this part in the middle, which I hold onto the tin, if I could cut it open, it's going to open up like a rectangle. So I will have a rectangle and I will have 2 circles connected here. So what you know, over there, 2 circles connected, one at the top and one at the bottom. So what you do, you're going to do this to make a cylinder, and the circle this side and the circle that side, and then you will have a cylinder like I have. So you need to be able to recognize the nets. Then 2 more things, then we're done. You have to look at the 3D shapes as well, and you are going to sort them into groups by looking at the shape of the edges. Is it a straight edge or is it a curved edge? So if it's straight like this, you will put it in one column, and if it's curved or bended in any way, it's going to be in a different column. Then there's another activity that you have to figure out which of these 3D shapes I can stack. Now stack means I can build. So I can take the rectangular prism, it's almost like Lego blocks, and I can just, where's my other one? There's my rectangular prism, and I can put another one on top, and it can be stacked. I can take my cube, and I can take my cuboid, and they can stack. Okay, I can take my cuboid and the cylinder and they can stack, but I cannot stack it like this, it's going to roll off. I can take the pyramid and I can stack it. Okay, this one's blank like that, so let me take another one. There you go. I can stack it this way to make a tower, but can I do it this way? No, I can't even do it that way, it will slide down. So you have to figure out which of these shapes. So if I talk about pyramids and I ask you, can you stack pyramids? You need to imagine that 2 pyramids. Can I stack them? No. Can I stack them? Maybe like that. Okay. But pyramid, like we see them in Egypt, we can't put another one on top. They're not a fallen pyramid. It's a right standing pyramid and you can't stack it. Also, you are going to investigate, and all these things that I'm talking about, guys, you're going to use that things that you made today. You first have to do the building today. And when you build it, then you can check out the faces, the edges and the vertices. You can check out the nets before you start building it. And you can see if they can stack. And you also can see if they can roll. Yes, a cylinder will be able to be rolled. But can I roll a pyramid? No, it won't. There's only one, but I see I don't have an example of this one. And I wonder who took this away. If I take a circle and I inflate it and I have a round object, that's called a sphere. It's like a marble. It's like certain sweeties, like Astros. And it's like a ball, of course, a soccer ball, that's a sphere. Okay? You spell it S-P-H, but you don't say spear, you say sphere as if it's an F. Okay, guys, I spoke a lot of stuff, but it's all important things and I didn't want to make more than one video because I'm not sure you will watch more than one video. So I hope you enjoy all the activities. It's all fun stuff and all different ways that you can study the 3D shapes. And then on Friday, you will write a quiz doing ordinal numbers, first, second, third, and those things, as well as the 3D shapes. It will be all in one quiz. Have a lovely day.